Hello, this is Mrs. Jacoby, and welcome to the first in a series of review videos for the AP Human Geography exam, which will take place May 2026. Today we'll be reviewing Unit 1, Thinking Geographically. Hit that like button and subscribe for more reviews. A key question that geographers ask is, how do we analyze the world spatially? Well, it's all about the data. By using maps and geographic data, looking for spatial concepts and patterns, trying to understand scale and geographic analysis, analyzing diffusion patterns in different regions, and finally, knowing geospatial technologies, which help scientists collect data. Let us first answer the big question: what is human geography? Human geography is the study of spatial patterns of human populations. Geographers will always ask three questions. Why are things located where they are? How do places differ? And how do spatial relationships influence people? We can boil human geography down to a key idea: the why of where. In terms of geographic perspective, we look at spatial patterns. Where are things located in relation to other things? Relationships between places. Do places interact? And then human environment interaction. How do we as people interact with the natural environment? The geographer's most important tool is the map. Mapping data helps geographers to visualize patterns, compare different regions, and analyze spatial data to look for patterns. There are two different kinds of maps that geographers and people use. The first is reference maps. Reference maps show location of places and geographic features. Some examples are political maps, which show borders; physical maps, which show natural parts of the earth. These maps are used for navigation, general orientation. They're designed to get you where you want to go. The second kind of maps are thematic maps. And thematic maps are created to display specific information so it can be analyzed. Thematic maps are data creation tools to help understand patterns. Examples of thematic maps include population density. Where do people or animals live? Income. Businesses use this to add stores to areas that may be profitable for them. Climate maps. Always know what to expect in terms of weather anywhere in the world. There are many types of thematic maps: choropleth maps, dot distribution maps, proportional symbol maps, isoline maps, cartograms, and flowline maps. Let's look at these. Choropleth maps use shading or colors to represent values, as you can see in the picture. Any values can be used, and lots of different values can be represented on a single map. Income levels, literacy rates, or election results, which is what I'm showing, which lets you know which states voted Democratic or Republican in this election. The strength of this map style is it's really easy to see regional patterns. Dot density maps use dots to represent a quantity of something. The more dots in a region mean the more of whatever value is in that area. For example, population distribution maps, like the one shown, show areas of high population in the world. The dot density map here shows large concentrations of people in China and India, East Asia. The strength of this map is it shows spatial concentrations. Proportional symbol maps to give value differences. Symbols may vary in size to represent data values. The bigger the symbols, the greater the value. Examples: city populations. Larger cities would have bigger symbols. Trade volume of products or resources that countries make, grow, dig, or buy can be shown. And you can have multiple products on one map. Isoline maps are about connecting values across distances. We use lines connecting equal values. Some good examples are elevation maps. Topographic maps show how steep or flat an area is if you want to go hiking. Temperature maps. Where is the cold front sitting? And when will it leave the area? Rain or snowfall. Will we get out of school today because snow is moving in? Cartograms are used to show one specific value. Cartograms will distort a map or map shapes based on the data that you've plotted. Example, the one shown is a population cartogram, where China and India are the biggest because they have the most people, and if you look, it's really hard to see Canada. A GDP cartogram, ranking countries based on how rich they are. The US would be the biggest or on top in that one. Map projections are how we take our spherical world and flatten it out. Because you can't fold up the world and carry it in your pocket. The problem with flattening our world is distortion. Distortions affect the shape of countries, the area or size of places, countries, the distance between places or countries, and the direction of movement between places or countries. We call that sad. All maps are sad. Some are less sad, some are more sad. You must choose the map projection that works for what you need to analyze. Let's look at two map projections. The Mercator projection is sad. It distorts area. It preserves the direction with nice straight lines, even though the world isn't straight. So that's a strength. But its weakness is as you go out from the equator, it distorts the size of countries and they get bigger as you move toward the poles. Greenland is not that big. Greenland is not almost the same size as Africa. It's a lot smaller, 14 times smaller, in fact. Now, the Peters projection is sad too, but it distorts the shape of countries. The strength is that the areas are a lot closer than in the Mercator projection. But the weakness is, if you look at the map on the screen, they're long and skinny on all the countries. So it looks a little odd to us. Spatial concepts are important because geographers need to know where all the stuff is. We have 5 important spatial concepts: location, space, place, scale, and pattern. These help geographers understand how phenomena are arranged across the Earth. Good example of place is absolute location. We use exact coordinates or a specific location of a place. With exact coordinates, we're talking latitude and longitude. They use coordinates. 40 degrees, 0.7128 north by 74 degrees, 0.0060 west is a specific place on Earth. Now we can do location in another way. We can use an address. 3956 Blaze Drive is where Blackman High School is located. New York City. Now, that's much less specific, but it is still a location in the United States. Relative location, on the other hand, describes location relative to another place. For example, Memphis is west of Nashville. We can go smaller. The O'Reilly's Auto Parts is next to the Burger King on Mount Juliet Road in Mount Juliet, Tennessee. Now, distance decay focuses on how much the two things, the two places, are involved with each other. Now, on the graph, I'm showing you that interaction decreases as distance increases. You can see at the 0, 0 point, interaction is a lot. And as you move out and go farther away, the interaction drops. Some examples. I live really close to Nashville, so I spend a lot of time there. I interact with it. But I live 4 hours from Memphis. I've never been there. I don't interact with it. Another example, trade flows. Countries close to each other are going to trade more than countries that are farther apart. Cultural influence can be mapped. We are much more influenced by Canada and Mexico as compared to New Zealand because Canada, Mexico, and the United States are all part of North America, while New Zealand is part of Oceania. Time-space compression is all about feeling close to others. The Earth is not shrinking, but it feels smaller because we can get to places faster with new technology. Time-space compression is a reduction in travel time due to technology. Examples of a compressed world include traveling across the oceans. As you can see on the map, the time it took to travel 200 years ago was months, while I can fly across the ocean to Europe in 5 to 6 hours. The internet's even faster. I need information, I can get it in seconds. Now, the impact of time-space compression is increased globalization because we can see and touch and taste so much of the world now. Scale of analysis is next. This is a big concept. Scale refers to the level of analysis that we are looking at data. Global issues affect the world. We're not going to find pet adoptions at this scale. It's too big. Regional issues are going to affect continents or really large areas. National issues are going to affect countries. And local issues, or the local level, will affect cities and towns and villages. Speed limits, and this is where you're probably going to find pet adoptions. Different scales reveal different patterns. You must choose the correct scale of analysis to use to find the data that you need. Types of regions are used to analyze areas. Regions are areas that share characteristics. There are three types of regions: formal regions, functional regions, and vernacular regions. Formal regions are also called uniform regions because they are defined by one uniform characteristic. Examples: language regions. There might be one, possibly two, dominant languages. North America is mostly English, except for that tiny little part of Canada that loves its French in Quebec. Climate regions, areas that are going to be regionally hot, they sit at the equator. Areas that are going to be regionally cold, they sit more at the poles. Political boundaries, borders around a region, city limits of a town or state. Please remember, I'm going to say it again, formal regions are also called uniform regions because of those uniform characteristics. Functional regions are organized around a central node of some type. Metropolitan areas around a city hall. Transportation networks around a central station. Television markets around where the transmitter sits. Pizza delivery or an Uber Eats delivery zone only deliver out to an area around them. How about this? Your school. Your school is at the center of the zone of neighborhoods where you go to school. Now, functional regions are also called nodal regions because of that central point called a node. Vernacular regions have no factual connection. They are perceived based on culture or opinion. Examples here are the South. Lot of definitions of the South. Could be the Confederate States, could be where there's less snowfall. For me, if I can get sweet tea, it's the South. The Midwest is perceived as an area of lots and lots of tornadoes. Although tornadoes are hitting south more, Tennessee. Silicon Valley. This is a place where tech companies like to locate, out in California. Vernacular regions are also called perceptual regions because it is how we as humans perceive the area. Diffusion is the spread of ideas, goods, or people over space. Many types of diffusion can occur. The two big types is relocation diffusion, where you physically move and take a trait or an idea with you, or expansion diffusion. The trait moves without you moving. Now, hierarchical diffusion or reverse hierarchical, contagious, and stimulus are part of expansion diffusion. Hierarchical diffusion, the trait moves from big to small or rich to poor, or reverse hierarchical, where the trait goes from small to big or poor to rich. Contagious diffusion spreads through contact, like a virus, person to person. You say a word, and the person next to you thinks that's cool, and they're going to say the same word. Stimulus diffusion is only part of a trait spreads to fit in a new area. McDonald's is in India, but they don't sell a Big Mac because that is beef, cow. So to adjust, they have the Maharaja Mac. Cows are sacred, not eaten. So it's a chicken patty or a veggie patty. Geospatial technologies include all the tools we used not only to collect data, but to analyze data. The Geographic Information System, or GIS, is used to look at data in many layers. The GPS, or Global Positioning System, is how we know where things are. Your phone is tracking you at all times. If your GPS is on, it knows where you are. If you're in a car, it knows what speed you're going. And then remote sensing. This is taking pictures from the air in airplanes or from space using satellites. These technologies collect and analyze spatial data so geographers can once again look for patterns. Let's try a few practice questions. Question number 1. Which thematic map uses shading to represent statistical data by area? Is it A, dot density? Is it B, flow line? Is it C, proportional symbol? Or D, chloropleth? I'll give you a few seconds. Did you guess? The answer is D, chloropleth. A chloropleth map uses shading. Remember the political map we looked at? Let's try another one. Question 2. Which concept explains why interactions between places decrease as distance increases? Is it A, scale, B, diffusion, C, distance decay, or D, regionalization? Once again, I'll give you a few seconds to look at this. If you answered C, distance decay, as you move away from someone or someplace, you interact less, you are correct. Question number 3. Which type of diffusion occurs when a cultural trait spreads through direct person-to-person contact? Is it A, contagious diffusion, B, hierarchical diffusion, C, relocation diffusion, or D, stimulus diffusion? Take a few seconds now. The answer is A, contagious diffusion. Just remember, it works like a disease or a sickness, person to person. And last question, question 4. Which map projection preserves direction but distorts the size of land masses near the poles? Is it A, Peters projection, B, Mercator projection, C, Robinson projection, or D, conic projection? Take a few seconds. Did you say Mercator projection? If you did, you are correct. The Mercator projection distorts the area of land masses as you move away from the equator. It is sad. Let's take a quick look at a single piece of an FRQ. Look at the task verb. Do what it tells you to do. In this case, explain says talk about what it is and give examples. The sentence is explain how scale can influence geographic analysis. Well, you should discuss what scale of analysis is. Then discuss how different patterns are visible at different scales. And finally, you should be able to give examples, say global scale versus local scale, and what you're going to see. Unit 1, let's look at a summary. Key takeaways. Geography studies spatial relationships, where stuff is and why. Maps will reveal patterns, especially thematic maps, which is what they're designed to do. Spatial concepts can explain human activity. Regions are used to organize geographic space. Remember those three regions: uniform, functional, vernacular. And GIS technology improves analysis by giving us a way to look at a lot of data in a very organized manner. Thank you for watching. Be on the lookout for Unit 2 review. We'll be talking about population and migration patterns and processes.